I'm going to talk about vision language models and multimodal models. I use these terms interchangeably. Through these 2 days, we heard a lot about it. And to be honest, part of the stuff that I'm going to talk about here is going to overlap with, bless you, with some of the stuff that you have already heard, especially in the keynote. But I'm going to at least try to steer this in towards some direction that you can hear something new as well. So, vision language models. If you go back about 3-4 years ago, we had this type of BERT-based model. Like, BERT was a big deal. It was about 100 to 400 million parameters. It was working, and people were trying to figure out how can we connect it to images. So the very first natural approach was just pass in image tokens. And these image tokens were passed in the same space to the same model as BERT, and then they were trained together. Now, one of those, when you look at this, one of the key differentiator was, because it was BERT, it was a masked language model, which means when you're training this, you kind of drop some of the tokens, and then you're going to predict, hey, what was that word that is missing in this sentence? That's how BERT was trained. That's how this sort of visual BERT system was also trained. So you also had this image and class tokens in there as well. And this was good if you wanted to generate captions. Like, hey, I have an image. What's write a caption for this image? It's like, hey, there's a dog. There's a cat. Dogs and cats are fighting. Then around 2021, 2022, this type of dual encoder network started to appear. So you had one network for the visual encoder, vision encoder, and another network for the text encoder. And the text encoder in here, they are about the size of a GPT-2, about 400 million parameters. They are pretty small. Their whole job is to guide and train the vision encoder. Like, you train this dual encoder, and then you just delete the text encoder, and you end up with a vision encoder, and you call that clip. And this was a big deal. At the time, it could align text tokens with the image tokens. And when I say tokens, they're basically words. Like, a sentence is 3 tokens, a sentence. Image tokens is the same. We're basically breaking down the image into a bunch of words, and each word is just a patch in the image, and that's how we treat the image. It's a fancy way to say image to column tokenization.